top row of angles is called central angles. So remember, that was our vocab word for describing an angle that has a vertex at the center of a circle, versus the ones down here, we call those inscribed angles because they have a vertex on the circle. So we've looked at the measure of angles before in our class, like the measure of like how wide this angle is. And today we're also going to be looking at, well, how wide is the arc? So we're going to be looking at degree measures of the arc. So we know a total circle is 360 degrees, so we're going to figure out, well, how many degrees does a smaller arc have? So that's the idea of today. So first up is central angles. So for our central angles, these are the easiest ones because the central angle reaches its angle arms out and intercepts part of the circle. So that's called the intercepted arc. And the degree measure of the arc is equal to the degree measure of the angle. So in this picture, since the degree measure of the angle is 50 degrees, so that opens up 50 degrees wide, that means that this arc is also opening up 50 degrees wide. So central angles are the same. So for example, we're going to use that to find a lot of missing things in this picture. Whenever we are looking at these kinds of problems, I'm going to ignore the stuff on the right for now because they don't necessarily go in order. So I'm just going to help you guys fill in as much as we know on the picture, and then we'll go back and we'll fill in the stuff on the right. So for example, if we look at this inscribed angle right here, I'm going to trace out my angle arms to see how much arc it's intercepting. So the intercepted arc of that angle is right here. And if that angle is 136 degrees, that means that arc HL is also 136 degrees. So I'm writing that in my picture because we might use it to help us find something else later. So that's why I'm going to write all these little pieces in our picture. And let's see, the other thing that I see as given is this little piece right here. What does this mean? Is 90 degrees. So we're looking at this angle right here, the IPK angle. I'm expanding its angle arm so I can see what's in between. So the arc I all the way to K is what's in between that angle. And so that means that if this angle is 90 degrees, that all the way from I to K, that arc is 90 degrees too. Which is going to be helpful because we are told that from J to K is 62 degrees. So if the whole thing from I to K is 90, and we've already used 62 degrees, we can figure out how much is left for just I to J. So I'm going to do 90 minus 62. And so we get what we have 28 degrees left for just the little I to J piece. So we're writing all these little pieces in our circle because we're going to use those now to find the other pieces that are missing. Okay, so now we want to find this piece right here. Let's find the degree measure of arc HN. So we've already used half of a circle have 180. So when you get stuck, you can look for half circles. Let me try this again. And that will help us find missing pieces. Yay. Okay, so for example, if we look at above this diameter that's drawn right here, everything above this diameter, that's a semicircle. So it should all add to 180. So we've already used 136 degrees of that semicircle. So we're going to do 180 minus 136 to figure out how many degrees we have left for the little HN piece. So 180 minus 136 gives us 44 degrees for that HN arc. Which means this angle down here, this is a central angle because its vertex is on the center of the circle. If the arc was 44 degrees, that central angle is also 44 degrees. All right, next up, let's find this little piece right here. Let's find LK. So the way we can find LK is with vertical angles. So remember, vertical angles, that's a throwback. That's when we had two lines crossing in an X, and we said that the angles across from each other are the same. So we called these vertical angles. So we've seen these off and on throughout the year. So we have vertical angles in this picture. That 44 degrees and this angle right here are vertical angles. So that means that they're congruent. So if one of them is 44, the other one's 44. Which means that arc LK is also 44 degrees because it's the same as the central angle. All right, so last but not least, we have one more missing piece. We have this NI piece that's missing. So we can use a semicircle to solve for that piece too, because we know that from N all the way around to L is half of a circle, so that should be 180 degrees. We've already used 90 and 44 degrees, so we can figure out how much we have left. So 90 plus 44 degrees, let's see, that gives us 134 degrees. So we'll subtract that from 180, and so that leaves us with 46 degrees left for that little piece right there, which means that the angle that's intercepting that arc is also 46 degrees. So it's kind of like putting pieces together of a puzzle. You find one thing that helps you find something else. So now we can go through and fill in our little blank. So the measure of arc HL, that was 136 degrees. Then we have the measure of angle LPK. So let's see, L to P to K, that's that 44 degree angle. Remember that to find out where an angle is when it's with three letters, trace it with your finger, start at L, go to P, go to K. Whatever is in between where your finger turns, that's where the angle is. All right, we also have arc KL. So arc KL was 44 degrees. We found arc IJ, that was 28 degrees. Arc HN, that was 44 degrees. Arc IN, that was 46 degrees. Let's see, next up would be arc JL. That's a new one because it combines two smaller arcs. So all the way from J all the way over to L. So that's going to be this 62 degree arc plus the 44 degree arc is JL. So 62 plus 44 means that arc is 106 degrees. All right, and last but not least, arc HJ, so that's the same thing. So that's another arc that combines multiple arcs together. So start at H and you're going towards J. So we have that 44 degree arc plus 46 degrees plus 28 degrees. So 44 plus 46 plus 28 equals 118 degrees. Okay, I'm going to let you guys try number 2 for a couple of minutes before we do it together. I'm going to write a little list up on the board to help you guys think about what to do when you get stuck. So what you're doing first is you're using all your central angles, and you're using central angles to label arcs. If you get stuck on central angles, you're looking for semicircles because semicircles add to 180 degrees. And you can also look for vertical angles because vertical angles are congruent to each other. So those are the 3 things that you're going to be using to try and find those missing pieces. So start that with your table, and I can come around and help you if you get super stuck, and then we'll check it together. This is the center of the circle, so this is the diameter. So this is the same Okay, let's see. Don't add your own lines. Yeah. This one. Oh, you go. So and so then same situation for these last two guys. Okay. Just change J and also J and L is actually the same together.
That's what you're
Okay, so real quick, just to go over it with you guys, you seem to be doing really well. Since this arc right here, JK is 70, this angle right here is also 70 degrees because it's a central angle. You can use a semicircle to say, oh, all these three should add up to 180 together. So we've already used 70 and 70 here, which means 180 minus 140 gives us 40 degrees left for this guy, which means this angle is also 40 degrees because that's a central angle, which means this one's also 40 degrees because that's a vertical angle. So this one's also 40 degrees because it's a central angle. And then we can use a semicircle situation again to look at this semicircle and say, well, this should all add up to 180 also. We've only used 40 degrees in that semicircle, so we have 140 left for that piece, which means this big angle is also 140 degrees. So arc IJ was 70, JMK was 70, arc HI was 40, LK was 40. To find JML, we trace from J to M to L, so that's what's in between is the angle. So 70 plus 40, or 110 degrees. So we can do the same thing for HML, so trace H to M to L. What's in between is the angle, so that's 140 degrees. And then HL is this arc right here, that's also 140 degrees. Just one note, whenever you see an arc named with two letters like HL, that means you're going the short way around on your circle. So that's why you know to go this way and not take the other direction around your circle and add multiple arcs together. Because when it's only named with two letters, it's a minor arc, so that means it's less than 180 degrees. Okay, you guys okay so far? Cool. All right, inscribed angles. Inscribed angles are more fun on the back side. So inscribed angles have the vertex on the edge of the circle, and their special property is whatever the angle is, the arc that it intercepts is double that. So for this angle right here, angle B is inscribed. We trace out its angle arms. It's catching arc AC in between. So if the angle is 50 degrees, the arc is 100 degrees. So that's a special property of inscribed angles. So we'll kind of do the same thing. I'll try 3 with you guys, and then I'll let you guys try 4 on your own. So we're going to go through the similar steps. So first, we're going to use the inscribed angles that we've been given. And there's a lot going on in these pictures, so if you have colors that you like to use, you can pull out your colors, like highlighters and things like that. First thing I notice is this 52-degree angle. Let's see if this will be useful. So I'm going to trace out the angle arms of my 52-degree angle and see what arc it intercepts. So that 52-degree angle catches arc BF in between its angle arms. And so since the 52 degrees was inscribed, because its vertex is on the edge of the circle, the arc is double the angle. So that means that the arc is 104. All right, we can do the same thing with the 21-degree angle. So our 21-degree angle is also inscribed. I'm going to trace out his angle arms to see how much arc he catches in between. So in between the angle arms, he's catching arc AE. So since 21 degrees was inscribed, the arc is double the angle. So the arc is going to be 42 degrees. Okay, so now we've used all of the inscribed angles that we've been given. And let's see if we have enough information already to fill in all of our blanks, and if we don't, we'll come back and solve some more things. So arc BF, so that's from B to F, that's 104 degrees. Arc AE, that was 42 degrees. Let's see, angle EBD. So if I'm tracing that with my finger, I'm going from E to B to D. Oh, we haven't found that one yet, actually. Okay, so angle EBD is right here. So we need to figure out how much that angle is. So we're going to kind of work backwards on this one, because angle EBD, if you stretch its angle arms out, he's catching this arc that's 75 degrees. And we know that the angle that's inscribed, we double that to get to the arc. So if we have the arc, we're going to divide that by 2. So 75 divided by 2 gives us 37.5 degrees for that angle. So the arc is double the angle is half the arc. I think we're going to have to do the same thing for angle 1. Yeah, so angle 1's right here. So if we trace his angle arms out like this, angle 1 is catching that 104 degree arc. So for inscribed angles, the arc is double the angle is half the arc. So we're going to do 104 divided by 2 to get 52 degrees for angle 1. And then last but not least, for arc AB, we haven't found that one yet either. That's this guy on the top left. So let's think about our strategies that we had on the previous page. On the previous page, we used semicircles, but on this one, we don't have any semicircles drawn for us because there's nothing going through the center of the circle at point C. So the other thing that you can do is you can use the whole circle, because we know that the whole circle adds to 360, right? So we can figure out how many degrees we've already used and then subtract from 360. So we've already used 104 plus 41 plus 75 plus 42 So we've used 260 degrees, and we're only missing that one arc. So 360 minus 262 gives us 98 degrees left for that arc, AB. So if I'm adding to your list of strategies, if we go back to your previous page, I'm going to say semicircles and whole circles are something else that you can look for, because whole circles add to 360. So if you're keeping a list of your strategies, that's another one that you can that you can use. Okay, I'll let you guys try number 4. Number 4 is a little bit tricky. It's asking for some inscribed angles and some central angles. So it's kind of combining the front and the back of your notes. So give it a shot, and then I'll solve it with you in a little bit. So it's kind of like a puzzle. So if you need help knowing where to get started, I can come by and help you out with that too. Okay, so now your stuff. Okay, so since you've used the angles that were given to you, go to step 2 and look for semicircles and see if that helps. It does. Yeah, good. See, I love using colors. So good. Don't we have to get started? Okay, so the first one is use the angle of the radius. So they give you this from yeah, because it's inscribed, yeah. So we're reaching the angle arms out, and we're seeing what arc is in between. So the arc that's in between the arms is going to be C. And we can use this arc right here. So DE, let's find out what angle goes back to that. So go backward. Now we started 44 going backwards to 22. Where would that angle be? So follow these. So DE, follow that guy all the way back. Right here, right? That angle right there. So this guy is 30. 15. Because just like we doubled to get to the arc, if we're already at the arc, half it to get back to the angle. So this guy's 15 right there. Yes. And actually, it's this angle right there. And that's kind of what we're on the picture. And that's going to be the that's a different one. Oh, EBD, that works with E, D, D. And then next, look for semicircles. Right, you have any semicircles that will help you find this and see if that helps. Yes. Okay, how did you get 68?
I just subtracted 1.
Okay, so this is actually a central angle, right? So that's back to the color on the front. So it's actually the same. Yeah, so change out that one. And then, I don't think that this part is 15.
Wait, so what is this whole triangle?
Triangles always equal 180.
BD. What is the
Wait, which one are you trying to solve?
Those tabs, all of those are there's no logic on this correct except this one. That's what we can try to figure out.
Redo that one. And this one. Yeah, redo the DED. And then the other one that I can do the F.
So this one and
That one.
this one.
Yep.
So I see.
Yeah. Let's see. I'll go in order. So I'm going to try to fill my work first. So since you're step, go to step 2 and let's look for some semicircles. Do you see any semicircles in this picture?
Yes, right.
Yeah.
Yeah,
And look, actually, we're on the same arc, right? So do that next.
BD should be. What's 44?
So helpful if we can find one of
I
these
saw for the
guys.
wrong angle.
Let's
And
find,
those two I did 2
Yeah, we saw for the
let's
wrong
find this
angle.
angle right here.
So just 44.
Yeah, just 44, right? Because it's a central angle.
Oh, yeah.
Mm-hmm. Which means how much is this one?
44 also, so then this is 40.
Yeah, you got it. You got it. Yeah. Let's see. This one and this one.
I don't know, but for this second.
50.
Yeah.
This is, I'm just trying to
Oh,
get
so this
I'm
is a
struggling
central
with
angle.
BD.
Instead of back in the front of your notes, or is it central angle the same? Oh, this one's actually right there. It's, yeah, it's central if the vertex is on this compass. That one is the T next to that one.
So,
That's all your arcs are good.
So this would be 44 now.
Yeah. Try this one again. And
You should look
this
at
one, and this one.
every turn that's equals one thing, right? So you should be,
So first step, remember to look for semicircles and see if that'll help you. There's a semicircle on the bottom
These triangles
also.
equals 180. And see if we can count 57.
Yeah. Ooh, okay. So this angle right here is actually a central angle because this vertex is at the center. And so if you're stretching out his angle arms, look at what's in between, right? So BF is in between. So this is 136. This is also 136.
Oh, and then you try that, right?
Well, because you don't have to divide by 2 though, because central angles is back to the front of your notes. The central angles are the same as what they have. Yeah, so this one kind of combined the central and inscribed. So if there was 136, this angle right here is still 136.
Will these ones do 82.5?
So, I'm stuck, because I got everything, I think, no, I got this correct. This is what, we got everything right.
So VE, that's this angle. Let's follow the angle arms out. This angle arms go up to here. How much is between the angle?
180, so it's 90, it's 90, right? It's 90, thank you.
Good.
150 divided by 275.
Okay, but you didn't okay, great, great. Fabulous. Let's find this angle right here. It is, yes. Well, how much would this angle be? That one's 44. 44 also. Okay. Now I would go back and see if you have what you need. Because now we have, oh wait, you did this one, right? Yeah, you got the 136. Yeah, because it's semicircle, right? It's an arc. That's right. That's right. Yeah. It's actually not. So because so B, D, E. So what's in between my fingers? How many degrees?
180.
180. So this angle is inscribed, so we're going to do half of that.
So half of 180.
To get 90.
Okay.
So just add up everything in between where your finger goes.
Oh.
Try the last week again. Okay guys, I'm going to start going over it with you up front so you can check your work. So the first thing I did was look at this angle right here because that was given to me inscribed. So I traced out his angle arms and said, okay, if he's 22, the arc in between his arms is 44 because the arc is double the angle. The next thing that I did is I used this arc DE and I went backwards to find the angle again. So I traced the angle arms backwards to B and said, okay, if the arc is 30, we're going to half that to get to the angle, because the angle when it's inscribed is half the arc. So that one's 15. So after you do that, though, it's like, oh, I've used everything that I have. What can I do? So that's when I would go back to your list of strategies and go to step 2 and look for semicircles. And we do have some semicircles. Like this one right here is a semicircle. That should all add to 180. So that's what I did next. So I said, okay, so 30 plus 44, subtract from 180, means I have 106 degrees left for that arc right there. Okay, so then I'm thinking, okay, I don't have enough information to do a semicircle on the top half of the circle. What else can I do? We've already done stuff with inscribed angles. We haven't done anything yet with central angles, but there are central angles in the picture. So that's what I did next. I said, well, maybe it will help me if I find this central angle right here. So I'm going to trace out the angle arms of that central angle. And then I can see, oh, BC, that's 44 degrees. That's in between my angle arms. And central angles are the same as the arc. So if that arc is 44 degrees, that means that this angle is 44 degrees. Which means that this angle is 44 degrees because they're vertical angles. Which means that this arc is 44 degrees because that's another central angle that's reaching out and intercepting that arc in between its arms. Okay, so that means we can look for semicircles again, because now we have a semicircle on the top that we're only missing one arc for. So we can do 180 minus 44 to get that we have 136 degrees left for that arc. And I'm going to start filling in what I have and see if I have everything, and then we can solve for anything else that's missing. So BC was 44 degrees. EBD, that's this angle right here that we found was 15 degrees. Arc BD, so B to D, that's 44 plus 106, so that's 150 degrees. Let's see, angle FZE, so F to Z to E, what's in between is that angle, so that's 44 degrees. Arc BF, that's 136 degrees. Angle FZB, let's say I've colored so much on my picture I can't see where the B is anymore. FZB, okay, so FZB, that's this angle right here. Ooh, which I haven't found that yet. But if I reach out the arms of that angle, I can see that that central angle is intercepting an arc that's 136 degrees, which means that that angle has to be 136 degrees too, because central angles are the same as the arc. Okay, so then next up is angle DEB. Let's see. So DEB, that's from here to here to here. Okay, so we haven't solved for that one yet either, so I'm going to trace out his angle arms. So D to E to B, that's this angle right here. So we can see how much is in between that guy. So we have 106 degrees plus 44 degrees is in between those angle arms. So we can do 106 plus 44. So that's 150 degrees total in between the angle arms. And then our angle that we're looking for is inscribed. So we're going to do 150 divided by 2 to get 75 degrees left. To find BDE, BDE is a tricky one. So let's see. B to D to E. So that's this angle down here. So it is inscribed. And if we're looking at how much is in between his angle arms that we trace out, that's a whole semicircle, right? That's a whole 180 degrees. And so since he's an inscribed angle, he gets half of that. So 180 divided by 2 means that we have 90 degrees for that one. And then last but not least, for BDF, that means that we're just going to start at B, and we're going to add up all of the arcs until we get to F. So that's going to be 44 plus 106 plus 30 plus 44, which gives us 224 degrees. So these really are like a puzzle. I think puzzles are fun. If you think puzzles are stressful, let me know, and I can help you figure out kind of more of like a step-by-step process to go through when you're thinking about these problems. I also think it's really helpful to use highlighters or colored pencils. If you have trouble seeing like where arcs and angles are, I have other strategies. I can help you with that too. Any questions on any of these? You want me to go back and show you how I got any of these angles or arcs? Okay, well, if you want me to later, let me know. I love these questions, so I'd love to help you with it. So, first,